Okay, we're now going to do a lesson on understanding how motors work, in fact, DC motors. So, here's our heading, motors. And in order to understand how they work, there's just a few things we need to be clear on. And they are the following. We need to be clear that the force on a current carrying conductor is equal to Bill. So we need to be able to work out the size of the force when a current travels through a conductor. So it's equal to Bill sine theta. And we should know, or you should know, that at this stage, that B stands for the magnetic field strength. And that is measured in Tesla. I is the current travelling through the conductor. And that is measured in, of course, amperes. And L is the length of the conductor. In the magnetic field. Finally, theta is the angle between the conductor and the magnetic field. Okay, the second thing we need to be aware of is that the direction of the force, so this first dot point tells us how to calculate the value of the force. The second dot point is to work out the direction of the force. And in order to do that, we need to be able to use the right hand slap rule. And just to remind you quickly about the right hand slap rule, if we imagine our right hand, and I'll do that, I'll try and draw a right hand. Let's see how we go. So we've got our fingers pointing in this direction. So there's our fingers, and there's a little finger there. There's our thumb. And this is the palm of our hand here. So we need to remember with the right hand slap rule, the thumb represents the direction of the current through the conductor. The fingers point in the direction of the magnetic field. And finally, the palm, which is sort of coming out obliquely in this direction, represents the direction of the force on the conductor due to the current acting in the magnetic field. Now bear in mind that the current, the magnetic field and the force are all at mutual right angles. They are all orthogonal to each other. So the force has got to be at right angles to both the magnetic field and the current. So they're basically the two key ideas. The other ideas we're going to discuss, which you probably haven't seen yet, is the idea of a commutator. And that actually fulfills a very important role to keep the motor spinning in one direction. So they're a practical enhancement that allows the motor to keep turning in the same direction. Otherwise, it'll get stuck after not even completing one turn. So they're a very important thing, and we do need to be aware of how they work. And the motors that you're going to be building will actually have a built-in commutator. So they're pretty much the basic ideas we need to be aware of. So now what we're going to do is put these ideas together and show you how an electric motor works. And that will be in our next video.